Hi, I'm Courtney Pellicero, a student at the University of St. Thomas. This video is a project looking at flooding in Houston and exploring the accuracy of FEMA classified flood risk areas. In 2016, Houston was hit by back-to-back storms, causing major flooding. Just two storms killed 16 people, flooded nearly 16,000 buildings, and caused $1 billion in damage. Further, one-third of the properties that flooded during these two storms were outside of the Federal Emergency Management Agency, also known as FEMA, designated high-risk flood zones. In this map, the shades of blue show the flood zones, and the yellow and orange illustrate where flooding occurred outside these areas. If an area is deemed a 100-year floodplain, that means FEMA estimates there is a 1% chance of flooding in a given year, and the 500-year floodplains represent a 0.2% chance of flooding in a given year. After these storms, FEMA was prompted to redraw the floodplain maps and expand these risk areas as much as 20% in some regions. Then, in 2017, Hurricane Harvey impacted Houston, resulting in extreme flooding and raining. It was the strongest hurricane to impact Texas since 1961 and the first Category 4 storm to make landfall in the U.S. since Hurricane Charley in 2004. Harvey was primarily a flood event, unleashing 33 trillion gallons of water, setting a U.S. rainfall record, damaging 100,000 homes and rivaling Hurricane Katrina as the costliest U.S. natural disaster. One of the reasons it was so costly was because only 17% of residents that were flooded had flood insurance, and this was because these residents lived outside the FEMA-designated floodplain areas and therefore did not qualify for coverage. Ironically, Hurricane Harvey was the third 500-year flood in 3 years. This is a striking indication that the current systems of flood risk mapping might not be accurate. The authors of this article, who were not named, explain that although FEMA has some work to do, they save $4 in damage for every $1 invested in their hazard mitigation programs, which goes beyond just flood risk mapping. Further, the authors suggest Congress should put more of a focus on disaster mitigation, especially since Congress was considering cutting some of FEMA's budget. Now the question is, why Houston? What about this metropolis accounts for such frequent extreme flooding? One of the biggest contributors is the rapid growth Houston is experiencing. With urban sprawl comes more impervious surfaces, allowing for water from flooding to move through these areas instead of being soaked up. Also, as mentioned before, the FEMA floodplain maps are inadequate and current policies allow for development in these flood-prone areas. So, not only is Houston growing rapidly, it is growing in high flood risk areas. This graphic from the article illustrates the flooding outside of FEMA flood risk areas again. These blue areas represent regions that flooded but had less than a 0.2% chance of annual flooding. As the article mentioned earlier, Houston is growing rapidly. Here we can see this urban sprawl. Now let's move into the specific project. I used GIS to explore the accuracy of FEMA-designated flood risk areas. I used data from satellite images of areas that flooded during Hurricane Harvey and compared these areas to FEMA floodplains. Using these two sets of data, I specifically investigated, for each block group, what percentage was flooded and what percentage was in a designated floodplain. And further, what is the relationship between these two percentages? This map illustrates the 2010 FEMA 100-year floodplains, or in other words, the areas that had an annual 1% chance of flooding. This map illustrates the 2015 FEMA 100-year floodplains. Notice how the floodplains expanded over 5 years. Likely, it's a reflection of urban growth. This map shows a more detailed account of the FEMA floodplains in 2015. We again see the 100-year floodplains in red, but we also can see the 500-year floodplains in pink and the minimal flood hazard areas in green. The green areas have less than a 0.2% chance of annual flooding, so you could expect a very low chance of flooding in these areas. Further, if we lay the map of where the Harvey flooding occurred, you would expect some flooding in the 100-year floodplains and maybe 500-year floodplains, but likely almost no flooding in the green areas. Well, here we do just that. The blue represents what areas were flooded during Harvey. This is real-life data from satellite images, so that is why we see these straight lines that seem to cut off suddenly. We can already see that there is definitely flooding in all the different floodplains, but let's zoom in. Yes, we are seeing flooding everywhere, even in the green areas. This suggests the FEMA floodplains are not great predictors of where the flooding occurred. I used a model to look further into the relationship between the flooded areas and the designated floodplains. I took the flooded areas, created a raster, and then reclassified it as either flooded or not. To clarify this further, I eliminated the areas that were already water features, like lakes and canals, so it was clear what areas were flooded land. Here's the flooded land. Here we also see the flooding in the ocean, but this does not fall into any of the block groups, so it should be ignored. Next, I took the 2015 FEMA 100-year floodplains, created a raster, and then reclassified it as either a 100-year floodplain or not. From there, I used zonal statistics to calculate what percentage of each block group was in a floodplain, and then what percentage of each block group was flooded. I only used block groups that were located in the area the satellite image covered. Here are the output maps. On the top, we see the percent flooded by block group, and below we see the percent floodplain by block group. Now it is time to look at the statistical relationship between the flooded areas and the designated floodplains. If FEMA is accurate, then we would expect a strong positive relationship between the two that would be represented as a straight line in a correlational graph. Let's see if that is the case. Not quite. There seems to be a very weak correlation between the percentage of a block group that was flooded and the percentage of a block group that was in a FEMA-designated flood risk area. Further, if we use an ordinary least squares regression to calculate how much a designated floodplain is an explanatory factor for being flooded, we see that r squared was only 0.02 and the regression coefficient was 0.095. Although this is a significant, slightly positive relationship, the significance is mostly due to the large sample size. We can infer that being in a FEMA floodplain is not a great predictor of if you will be flooded or not. In conclusion, FEMA maps are currently inadequate, at least in Houston. With all the damage caused, lives lost, and money spent after flooding, flood risks must be assessed in a more effective way. This New York Times article suggested several improvements that need to be made to the current FEMA flood risk maps. Flood risk maps must be updated more frequently, and this requires more funding by the government. Also, these flood risk maps must factor in the future impact of climate change. Climate change will likely increase the frequency of extreme weather events and have other implications for the resiliency of a flooded area. Further, flood risk assessments must factor in the future impact of likely real estate development. If cities are growing and new areas are being developed, this will have an effect on what areas are flood prone. Another article suggested other improvements. First, we need to map all significant flood hazards, requiring a more detailed assessment. Also, hydrology should be used to determine the forecast of development impacts. And lastly, georeferencing maps should be created that can be used by local governments and local management organizations. Future research should look into the effectiveness and accuracy of new methods for assessing flood risk areas and partner with FEMA to create the most effective floodplain maps. Here we can see already several 2017 publications looking at ways to assess flood hazards. This should give us hope that better FEMA flood risk maps are possible. Here are the cited sources for this project. And lastly, here are the sources of data. Thank you for listening.